inequalities in two variables. And to introduce this topic, we're going to review linear inequalities in two variables. They look something like this, which we would read y is greater than or equal to 2x plus 3. And so what this is a mathematical statement that we can have true or false solutions to. Okay, so a true solution would be an ordered pair, an xy pair that we could plug into this and get a true statement. Alright, so if we wanted to know, for example, if the ordered pair, let's say 2, 3, is an ordered pair that satisfies this linear inequality, one way we could know would be to plug it in. Okay, so we plug in the y. Oops, fix that there. Plug in the x for the x and the y for the y, and we get 3 is greater than or equal to 2 times 2 plus 3. Of course, that's 7, so then we get 3 is greater than or equal to 7, which is not a true statement. So when we plug in this ordered pair to this linear inequality here, we get an untrue statement to the tune of 3 is greater than or equal to 7. So since this is not true, we say this ordered pair is not a solution to this inequality. We also say it is not in the solution region to this inequality. And of course, to remind you about that, we go to graph this. So remember, if we've got a linear inequality in two variables like y is greater than or equal to 2x plus 3, we can graph it. And what we will see is something like this, where the shaded region represents every coordinate pair that satisfies the linear inequality y is greater than or equal to 2x plus 3. And of course, when we plugged in 2, 3, we saw that it did not give us a true statement, so predictably the ordered pair 2, 3 is not in the shaded region. Alright, so again, we've got a shaded region above the line 2x plus 3, and that line is given by a solid line because our inequality is y is greater than or equal to 2x plus 3. So all of that is review. I show you that in order to let you know that graphing quadratic inequalities in two variables works much the same way, except instead of a straight line, like we just saw with a linear, we're going to have a parabola, which would correspond to a quadratic like this. Okay, so this time we've got an inequality symbol, but we've got y is greater than or equal to x squared minus 7x plus 10. So a degree 2 polynomial is the rule on the right side, and what that produces again is a parabola. So the same sort of things hold here. If we want to know if an ordered pair is a solution to this inequality, this quadratic inequality in two variables, then we can plug it in to see if we get a true statement. Okay, so here would be an example of that. If we want to know if 1, 2 is an ordered pair that satisfies this quadratic inequality, we plug in 2 for the y, greater than or equal to 1 squared. Oops. Okay, so we square 1, and then we subtract 7 times that 1, and then we add 10. Okay, so when we clean all that up, we get 2 is greater than or equal to, let's see, this is 1 minus 7 is negative 6, and plus 10 would give us positive 4. So what we end up with then is 2 is greater than or equal to 4, which of course is not a true statement. So we understand by doing that that 1, 2 is not a solution to our quadratic inequality. Y is greater than or equal to x squared minus 7x plus 10. Right? Now what I want to show you next is that this works out in much the same way as linear inequalities, insofar as we can graph them and get a pretty good idea of where all the solutions are found. So if we go back to our grapher, and this time we put in y is greater than or equal to x squared minus 7x plus 10, and we graph it. We get once again a solid line indicating the x squared minus 7x plus 10, and then we're shaded above it because it's y is greater than. And of course, so we understand this to mean that all of the solutions to this quadratic inequality are in this shaded region on our graph. So we might pick a point out like 4, 2, which is clearly in the shaded region, and then verify it by plugging in 4, 2 to the equation and checking it algebraically. Okay, so we believe 4, 2 is one ordered pair that satisfies this linear inequality. So what we can do is plug it in here. Say, is it true that 2 is greater than 4 squared minus 7 times 4 plus 10? Okay, well, that's going to give us is 16 minus 28, so that's negative 12, plus 10, give us negative 2. And then when we clean all that up, we see that the statement we are given is 2 is greater than or equal to negative 2, which is true. So we have proven that 4, 2 is an ordered pair, which is a solution to the quadratic inequality. Y is greater than or equal to x squared minus 7x plus 10.